Hey guys, so we are moving on to the last unit for the year. Woohoo, pretty exciting. So, unit 9 is going to be on polygons. What we're looking at today is just like the general different types of polygons, I should say. And a polygon is an enclosed figure with no circular edges. It has vertices, edges, sides, all that good stuff. This is two-dimensional figures, which is polygons. So the first figure we've already talked about, we're going to go through this chart and just figure out a couple different examples. So we know what a triangle is. We've studied a triangle, we did proofs on them. We know triangles pretty much backwards and forwards. So we know a triangle has three sides. Then we look at a quadrilateral, another concept we have gone over quite a bit. We know quad means four. This is a four-sided figure. And as we go down the line, pentagon is 5, penta means 5, hexagon 6, heptagon is 7, octagon is 8, and there's more sided figures. These are the main ones that we're going to need to know. A decagon is 10 sides. That's another important one. Now the number of triangles. For one triangle itself, we know that there's one triangle. I know this seems kind of like a weird concept, but it's going to help us when we look at the interior angles of these polygons. So triangle has one triangle, but a quadrilateral, we did talk about this. You can actually split any quadrilateral up if you connect two diagonals together. It splits it into two triangles. This works with a square, rectangle, kite, whatever quadrilateral you're working with. And then, as you probably guessed, if you look at a pentagon, if I draw a line here, and then now I cut this into one triangle right here, and then I have a quadrilateral. And just like before, I'm going to connect the diagonals of my quadrilateral, and I create two more triangles. So we end up with 3 triangles in this figure. Okay, let me just draw this a little bit better. It's kind of hard to draw these triangles. And as you probably guessed, hexagon, 1, 2, 3, 4. So we got 1, 2, 3, 4 triangles for this one. And it's just going to keep growing by 1 every time for each side that we add. Now, why this is important. The interior angle sum. We have come to know something. I hope that if you learned anything in geometry, it was that all triangles add up to be 180 degrees for their interior angles. Quadrilateral, same concept. We talked about this. Since it's two triangles, it ends up being 2 times that value of 180 degrees. So it ends up being 360 degrees. So you can probably guess that the next one is also dependent on the number of triangles that we can make. So 3 becomes 540. 180 times 3 gives us 540. And then we add another 180. We get 720. Then we get 900. And then we get 1080. Okay. So this in the notes I would definitely keep handy. It's just a nice little chart that we can refer back to. Pretty easy. So I'm going to continue on here. So the exterior angle sum of convex polygons. Convex is where all angles are going to push outward in a sense. So a concave is the other word that you've probably heard. So I can't do it with a triangle. You can't have a concave triangle. But for now, we're just going to call them convex polygons. This is a concept we'll get into later on. For the triangle below, label each exterior angle with its measurement and then find the sum of the exterior angles. So here we have 35 degrees. To find the exterior angle, we know that together they form 180. So we're just going to subtract that from 180. And we get 145 on the outside. And then up here, or we'll go to angle B. Same concept. These two together should form 180. So if we take 180 minus 72, we get 108. And then 73, or 180 minus 73 gives us 107. So interestingly enough, you add these together, 107 plus 108 is going to give us 215. We add that to our 145. We end up with that magic number of 360. So the sum of these exterior angles is 360 degrees. Now, different figure this time, quadrilateral. We want to label each exterior angle with its measurement and find the sum of the exterior angles. So it's the same concept though, because these are going to form straight lines every single time. So they're all adding to 180. which means we can do the same trick as what we did in the last one. Take the number, subtract from 180. So this one is going to be 157, 134. Take that away from 180, you get 46. Over here, 180 minus 96 is 84. And this one down here is going to give us 73. Okay. Sorry if I went through that kind of fast. But again, we add these up, you're going to end up with 360. So this is kind of an interesting concept. It's one that I kind of like to dig into deeper, but since I can't be face-to-face with you, it's a little harder to explain. But if you think about it, if we were to start with a triangle, and then we add a side, we get a square. And then we keep adding sides. Now we would have a 5-sided figure. It's not a great one. We keep getting more and more sides, but eventually, this is like, it's called a limit problem. We just keep getting these infinite number of sides until our shape starts to look more and more like a circle. And we all know that a circle is 360 degrees. It's kind of a cool concept. I wish I would be able to talk about it in person, but it is what it is. So let's keep going here. So here's the big formulas that you're going to need to know. Interior angle sum, total number of degrees equals n minus 2 times 180. Again, I'd like to discover some of this with you. The exterior angle sum is always 360, no matter how many sides, just like what we were talking about. But the total number of degrees, so if we look at a triangle, so let's say we have 3 sides. We plug in 3 for n, we get 3 minus 2 times 180. 3 minus 2 is 1. 1 times 180 gives us 180 degrees, which makes sense because all triangles add up to be 180. Now, the regular polygon interior angle measure. A regular polygon is something that we need to be careful about because a regular polygon has the same sides and the same angles. So you have to be careful with that. A square is a regular quadrilateral, but a rectangle is not, because if we look at a square, all sides are the same, all angles are the same. But if we look at a rectangle, angles might be the same, but the sides are different. So this one is regular. And then this one is not regular. Again, it just means all sides and angles are going to be congruent inside of the figure when we're talking about the angles. Well, technically outside too. Okay, so let's use these formulas to calculate the following. How many degrees are in a pentagon? Penta means 5, so this is a 5-sided figure. So we want to use this formula right here that we used with the triangle example, the n minus 2 times 180. So n equals 5, we plug that in, n minus 2 times 180, substitute out n with 5, 5 minus 2, and you get 3. 3 times 180 ends up being 540 degrees. And if we go back up to our chart, which we talked about earlier, pentagon, interior angle sum, 540 because there's 3 triangles. How many sides does a polygon have if its total number of degrees is 1260? So this time we're doing the reverse. We don't know the number of sides, but we do know what the final answer is. So what we can do is think about it like this. We know that our equation to get our final answer looks like n minus 2 times 180. So let's just set that equal to the total number of degrees, and then let's just solve for n. So the first thing is, let's actually get rid of this 180. We could distribute. It works that way too. But if you take 1260, grab my calculator here. I want to say this is 9. 1260 divided by 180, 7, excuse me. Don't know where I got 9. So we get n minus 2 equals 7. That's what this reduces to on the right side. We add 2 to both sides. N equals 9. That's where I got the 9 from. All right. And I should technically put 9 sides. So it's a 9-sided figure. What is the measure of each interior angle of a regular dodecagon? So a dodecagon is 12 sides. And this one, it tells us it's regular. And we're trying to find the interior angle. So we got to use this formula right here. The n minus 2 times 180 divided by n. So I'll just write that here so we remember it. N minus 2 times 180 divided by n. And for n, that equals 12. So we got 12 minus 2 times 180 divided by 12. So the top part, 12 minus 2 gives us 10. 10 times 180 is going to give us 1800. Divide that by 12. We get 150 degrees as our final answer. Again, not too bad. Just a lot of formula work, knowing where do you plug in for n and when do you set things equal to each other. Okay, just a couple more. Sorry, this video is kind of long. What is the sum of the exterior angle measure for a hexagon? So hexagon is 6, so n equals 6. And we're trying to find the exterior angle measures. So if you ever see a problem like this, remember the rule. Exterior angle sum, no matter how many sides, it's always 360. So if we were looking for the sum, which we are in this case, we can just go ahead and say 360 degrees. Works for any polygon. What is the measure of each interior angle of a regular pentagon? Try to find 2 methods to get this answer. I'm just going to show you one really quick. If we were together, I would change this and have you try 2. So I'm going to go ahead and it's pentagon, so n equals 5. So we got to use this formula that we used in problem number 3. It's the n minus 2 times 180 over n. So let's just go ahead and plug that in. 5 minus 2, 180 over 5. This gives us 3. 3 times 180 is 540. We divide by 5. Excuse me. Is 108 degrees. Okay, so another way you could go about doing this, since it's a regular pentagon, we know that the exterior sum of any polygon is 360, but since it's a regular, they would all have to be the same exterior angle. So we could take 360, divide that by 5, and we get 72. Think about how does that help us get to 108? If I have a regular pentagon, it is so hard to draw a regular pentagon, so please forgive me. Oh, that's bad. So 72 degrees is going to be the exterior angle. So that's this angle here, which means the inside angle, the interior, has to be supplementary with it. So if you take 180 minus 72, you get the 108, which is the answer that we wanted. Alrighty, that is it for this section. Let me know if you have any questions.